Hi guys, this is RK from Yours Credit Schools. So today's project is something on Apache Solr to query indexed data for analytics. And here we are the team. And so our total goal is all about like based on Google indexing or Google searching. We also have proposed one more model, something called better search engine for our own websites or for our own uh, uh, modules. So we have something called Solr indexing followed by Hadoop processing and Q Solr search and a lot to talk about. Now, the basic design is all about like we have downloaded a dataset from Elk, which has been a restaurant-based dataset or reservations or delivery. Everything can be considered in this particular dataset, and the dataset is very huge. It's all about like uh, almost 1.8 gigs. You can just look at the dataset. It's 1.8 gigs of a tar file, and we have downloaded the data and we're processing in a local system. So a lot of universities and lot of colleges been already implemented this challenge, and here we are also trying the same event in a different way. Now, what we did is we did something different because we are trying to work on a local system. So we don't need any servers to contribute our project. So what we did is like we have downloaded the biggest data sets called business.json. So it's in a JSON format, which is very hard, which is very hard for us to process. So it's around like 439 KB dataset, and we have one more dataset called a review dataset with 200 to 6 KB MB, so which is a very huge data. So for this, what we did is like because of our local system can't contribute much a lot on processing, what we made is like we took the business data and we made a conversion using Python, and we are making the JSON data to be saved as a CSV data or a tab separated data. You can see over here we're just converting the data set. So we're trying to use the Python language to convert the data sets, and here we are doing it. So we're trying to take the data set of JSON, and we're trying to Unicode and change the data sets with a tab separate, and replace all the tab separates with space. So we're going to get a clean data set now. And the same way we did the same thing for a review data set, and we just cleaned the data and we made it real. Now finally, you can see here, it's a clean data set. Now look at the properties. Now it's only 219 KB. So now everything gone into KBs. So same thing, we did the same property, and now look at that 176 MB. So lots of data has been changed and minimized using that thing. Now the second process is something called based on the two data sets, we've been using a small select query, and we are making the dataset, the two datasets into one for our analysis. So there's one dataset is completely based on business, and the second dataset is completely based on review. Now we are combining both the business and review together into one particular table, and that data would always look like something like this. So this is the final dataset. It's a bit clumsy. Now what we are trying to do is let us upload the data, and let us find what is the best search engine we can get on this. Now here is our challenge. We need Q to be installed in our system, so there are a lot of websites who can contribute how to install Q, and we have installed in the same process on Q. And the same way we got something called Solr. Also there will be a lot of websites working on Solr, so you can install Solr as well. So Hadoop, there are like plenty of videos how to install Hadoop. We need all the three properties. We need all the three. We need Hadoop, we need Solr, we need Hue. So based on our presentation here, so the presentation also says the same thing. You need HDFS, you need Hue, you need Solr. We have installed all the three properties now. Now make a configurations between all the three. Make them communicate between all the three. So that's how our things work. Now, as per our data set, I have shown something called the ELP data set of CSV of some size. Now we need to upload that particular data set into here, and then make Now, so as for the previous video, I have given a basic introduction. Now let us move on to the clinical factor, how we are actually trying to make the thing. So we made a text file same like at execution, so which has automatically take the considerations easily. So let's open a terminal, and what I'm trying to do is I'm traveling to my desktop, and there will be something called a video is a file, and inside that there will be something called final, and there is something called Solar Search. Now list of the files inside the Solar Search, I can find the lot. So here is about the ELK dataset what we discussed. So now let us put the dataset into Hadoop. So a simple command Hadoop fs-put will work to put your ELK dataset into home Cloudera. Sorry, I think it's user Cloudera. My bad. Now the data has successfully gone copied into Hadoop. Now the next process. Now the next process is something called, we need to upload the one of the file called schema. So how your data look like? Now let us upload the same schema into the Hadoop, into the Solar. Now you can see the third one, the data is being loading. Absolutely fine. Now the indexing is already been started. Now let me show you the result, how the data look like. So it's writing the file, it's working fantastic, indexing has been started. You can see everything here. Now the final data set, it needs some time to load, but the end result will be something unique. So based on the previous video, now let us go into the practical. So I've been sending this particular data set into the Hadoop. Now Hadoop has the data. Now follow the execution steps. Now what I'm trying to create something called an index director. What I'm trying to do is, for this particular data set, there will be a schema. Now the schema is already uploaded into your Solar. So now let me create a small index directory, instance directory. Inside the schema is already been pre-initiated. So it's already been sent over to, so they look at here. So the configuration files is completely uploading to your Solar. So all the things are going good. So the next point is, now let us work on, let us give some space to Solar to think about, or creating a chart. Now everything is done from our end. Now the next point is run your program. Run your program so that your job will be done to initiate the process. Now here we are. So now let us run this particular job, and let us see how the fruitful results will vary. So now the data is already there in Hadoop. Now the Solar was trying to work on the index. Now Hue is going to display the results. So it's just initiated, it would take some time. So this is our overall project. To get any data and post your data into Hadoop, and the process will start in a moment. Make it an index using Solar, and My bad, there is a small issue. I didn't find the right path, so maybe that's the issue being you can see. Go back to the location called solar underscore local. Maybe that is the bug I have done. So now again I can paste back the same command. Now it will start working on the process. So once the process has started, that's it. We're done with all the reporting. So wait until the process has started. Let it done the indexing. It would take a couple of minutes, but the end result uh, will be on indexing part. So you can see it's slowly loading up based on the reviews and based on the ELP dataset. It's slowly loading up. Now you can see on the data. So where exactly the restaurants have been there and what exactly you want to process, the output, anything can be measured over here. You can check on the maps, you can check on the